Hello, everyone. I'm just doing a sound check to make sure that everybody can hear me. This is Dave Gabala, and I guess congratulations for getting through the gauntlet and actually being able to log on to the webinar service today. Thanks for persisting and attending. Today, I'm going to be joined by Matt Mazzarell, who you'll hear from a little later, to share some of our capabilities around email compliance. So before I start, let me call your attention to a couple of housekeeping things. There's a couple areas in the webcast console that you'll want to be aware of. There's a Q&A module and at the very bottom, along the bottom bar, and I encourage you to ask questions as they come to mind. Throughout the presentation, you'll just type them in and we'll review and address those at the close of the presentation. There are also icons at the bottom of your screen to explore. There's a resources link, which will allow you to download the presentation, and a share icon that will allow you to send your colleagues or to share via social media. There is also a help button for assistance with any technical difficulties you might experience, and we found in the past that sometimes it's really helpful if you just refresh your screen. If you're on a PC, you can hit F5, and that will generally clear up most of any issues as a first step. Okay. So again, thank you for taking an hour out of your day to learn about our email compliance solution. I'll spend the first 20 minutes of the hour giving you an overview and show you how much time and money can be saved using our powerful text and graph analytics to inform and streamline any existing or planned monitoring processes. Just a short agenda. I'm going to cover 3 points in the next 20 minutes. Really, it is around setting the stage for what Matt is going to demo in the last part of the webinar. So I'll talk about what email compliance is and why you should be concerned about it, and then give you some examples and some statistics that show how important this is. And then the last part, I will just compare the solutions with what exists and is prevalent in the market today, and compare that to our analytics enhanced email screening process. So let me start by pointing out a fact that we all really recognize, and that is that the volume and complexity of our communication options have really grown during the digital age in the past couple decades, and it's really showing no signs of slowing down. We have multiple channels through which we can communicate. We can talk one-on-one with each other or broadcast to many people like on Twitter or on social media. And then the complexity of this is also increasing is that as we push more communication capabilities down to every employee so they can talk with just about anyone. The email and other digital communications give every employee the means to communicate with just about anyone, inside or outside of the company, and it's truly powerful. It accelerates the flow of information. It hastens the speed of business. But what about the potential downsides of this capability? To illustrate the breadth and depth of the potential problems here, I've pulled together some of the infractions that have been recorded in email messages. Things like criminal activities such as bilking investors or selling products or sharing information contrary to federal laws. Harassment and other employee misconduct can include things like excluding coworkers based on gender or race or age. And these all contributing a hostile work environment, which increasingly the courts are holding companies responsible for. Some of these may seem some of the other things that exist and are found in email may seem relatively benign, such as violating an IT policy for sending unencrypted usernames and passwords, or passing along jokes that are maybe potentially off color to some recipients. But increasingly, courts are holding your company is responsible for all of the activity that occurs and for, correcting these bad behaviors. So what I've done here is I've collected a few quotes from the American Bar Association that just highlight how important email has and other digital communications have become in this business world. This first one here was that email evidence showed that Lehman Brothers fraudulently induced investors to buy stock. It was critical in showing the wrongdoing. The second one shows anti-competitive behavior being chronicled in email. And then the third one is around UBS internal emails, referring to their product as knowing or reflected that they knew that their product was bad and was not, worthy to be sold on the market, but they were pushing them and, even talked about it as such. And then this last one, to show that it's really not restricted to just financial services. The American Bar Association even cited, Tiger Woods' incriminating text messages as really being the thing that toppled him. Rumors are one thing, but show the public text messages and it instantly becomes incontrovertible. So despite the fact that electronic data is, permanent and nearly indestructible and easily transferable, we, as users seem to view it and the other electronic communications with an air of informality that easily leads to getting us into trouble. So the examples that I cited by the American Bar Association are really just a few of the big ones that make it into the headlines. But really any digital message, whether it's internal to the company or external between, say, suppliers and partners or you and your customers, they can deliberately or, not deliberately, sort of unwittingly violate rules and regulations. And the bottom line is that, email compliance is not something that you want to leave to chance. So let me switch a little bit now and give you some idea of the magnitude of how important email compliance is. So here's an example from the financial services sector where the Foreign Corrupt Practices Act was put into place, and that was to prohibit offering bribes to any foreign official, regardless of whether it's customary and accepted in a different country, for any U.S. banks to offer anything to induce a deal to be made or to it would be important in a merger or an acquisition of a bank in a foreign country. So each violation of this act is punishable with a fine of up to $800 million, and prosecutions under this act are up by 600% in the past decade. In 2010, the Department of Justice extracted $1.8 billion in fines for violations of this act. Now, another one that is a little bit more slippery, that is, really difficult to contain, is insider trading, which, as we all know, is, illegal. Now, it's a little bit more complicated than that because insider trading can be legal because as long as the insiders buy and sell the stock and report it to the SEC, that's acceptable. But it can actually be illegal when you trade as an insider on non-public information or, and this is probably how we hear about insider trading violations the most, is when you tip a third party to act in a way that is, that they profit from this non-public information. So again, it's, every employee who has inside information is potentially a tipper that could get the company in trouble. So just a high water mark, in a couple of years ago in 2013 there was a fine levied against SAC Capital investment firm for $1.8 billion, and the SEC prosecutions of this have almost tripled in the past 3 years. And then this last pair of statistics that I'll share with you has to do. It comes from our largest bank in the country, J.P. Morgan Chase, where they report that they've spent more than $36 billion in legal fees due to non-compliance issues since they fell under higher scrutiny following the financial crisis of 2009. So JPMC has an internal communications surveillance unit of around 2,500 people, and their job is to help steer the company away from infractions. And some of the sophisticated things they've rolled out in terms of software, they actually have a software that tries to monitor email and communications and identify potentially rogue employees that are going to get the bank in trouble, and try to prevent it in advance. So if someone's at high risk, they will intervene, and they recognize how big of a cost this is for them, both in terms of money and reputation. So hopefully that kind of shows you the magnitude of the problem that can exist. And what I'm going to do now is just talk a little bit about the solutions that exist today and compare that to what we have available in the marketplace. So let me do a little bit of overview of the current approach that would be a point solution for email compliance. It's fairly simple. I don't want to focus on any one product in particular, but this is a simple schematic that is very generic and applies to most solutions out there. The first step would be collecting email logs and stripping out the attachments, because those solutions really just focus on the message. And then the second step would be passing the emails on to a screening process where known rules are applied to identify suspicious messages that would then be flagged for further review. And finally, the last step would be a manual validation process where an analyst would retrieve, read, and determine if this was a message that really required escalation or whether it was a false alarm. So some glaring shortcomings are pretty obvious, and I'll just touch on some of the biggest ones. In this first step, where we are actually discarding attachments, that really creates a large blind spot in the process, because as every user knows, as much as 50 to 70% of the data in an email is in the attachment. So, discarding those and not screening those is, like I said, creating a big blind spot. And then the messages passed on from this pre-processing step, the first step in the process, it actually contains a lot of noise in the form of bulk email, and that would be, we refer to that as spam, just, things that are sent out to a lot of people. Repeated text or echoes that get bounced back in replies. And then the other non-message content, such as signatures or disclaimers at the bottom of your message that say, please disregard if this is not intended for you. Anyway, so this sort of poor screening has a doubly detrimental effect on the downstream process of validation and escalation. It produces a number of false positives that should never have been screened to begin with, and it just sends in a lot of garbage into the system. So what that means is, the labor-intensive manual screening process bogs down, the workload is sort of untenable, and clients report that more than 90% of emails flagged for review by this simple process end up being false positives. So what I've done here is shown our process for our improved and optimized process using text analytics and graph analytics to help us be more smart about how we screen email messages. And so it sounds simple, but it actually has a very large impact. So we supplement the pre-processing step with much better scrubbing procedures. Network graph analysis allows us to remove all the bulk emails. And text analysis eliminates the echoes, the signatures, and the disclaimer text that are not part of the core message. so those don't require any scrutiny. And the reduction in message volume to be screened is reduced dramatically, so that the processing load downstream is significantly reduced. On top of that, we also embed our data analytics to update the rule set that is used for screening. So this continually updated set of rules means that the screening process can get more sophisticated over time as real threats are identified and fake threats get weeded out. So this reduces the amount of non-value-added manual work for the analyst charged with validating and escalating the flagged messages. So what I've done in this overlay is to highlight some of the advantages that accrue in this closed-loop system. The sheer number of messages passed through the process is reduced using our, relying on our text analysis to scrub them. We also end up screening the attachments via the same rule set. So that covers that blind spot. And in addition, we aid in the rapid search and retrieval of the messages, as this is a capability required by law once a non-compliant event is found. So failure to produce the message in a timely manner is itself a punishable offense that results in even more fines. So the reduced amount of noise going into the system, into the screening process, means that many fewer false positives are flagged for screening at the end. And so this slide that I put together is really to highlight the difference between the two processes that I just went over. Across the top, we took the old process, and as you can see, almost half of the messages were flagged for manual retrieval and examination, basically reading and possible escalation. So that requires a huge army of analysts at the downstream to handle that type of process. Across the bottom is our improved process enhanced with the text analytics and our graph analytics, and you can see that we reduced the exact same problem by an order of magnitude or more, significantly reducing the amount of screening that has to occur at the end of the machine learning part. So let me just spend a little bit of time previewing what Matt is going to show you next. These are the 7 apps that exist in our App Center that comprise the workflow, the work chain for our email compliance app. And so you'll find these in our App Center, and I've lined them up with which part of the process they address. I won't stay on this long because you're actually going to see Matt demo them for you. But before he does that, let me also, just to be clear about the analytics underlying this solution, that they are really flexible and generic, so they work on more than just email. Really, any digital message archive could be transformed and screened using our text and graph analytics. There's no reason you couldn't feed in web posts, text messages, tweets, etc. into the process. We have had discussions with clients to apply the same analytic sequence to call center transcripts and online community forums, where detection of non-compliant messages would be just the start. Additional things like topic identification and sentiment analysis methods would help identify problems and trends as they emerge. So there's lots of value to be had from this process of looking at the text deeply. This is a final slide, really just a preview of the types of output and graphs that Matt is going to show you as he demos our email compliance solution for you. So with that, I'm going to let Matt take over. It might take a second.
Okay, I'm just going to grab the screen.
Okay, just to introduce myself, my name is Matt Mazzarell, and I'm with the Field Applications team here at Teradata. And I've had a part in developing the solution on the ground with some of our clients, as well as making it general for you all today. And what we had the study on today is the Enron email dataset. It was made public around 2001 when the Enron scandal came out, and this has become a scholarly source of text data that many people have used to understand fraud since then. So what you're looking at right now is App Center, and you're looking at our email compliance app set. And the first app we have to share with you today is the Import to AFS app. And just to kind of set the stage, typically we see a lot of PST files coming in. Almost every single person in your organization will have their own PST file. And typically you'll store this all together in some repository somewhere. And what we have to do is we have to then move it to the AFS so that we can parse it very quickly into rows and columns and get all that email. So import to AFS app. And this is something typically that a DBA would do, maybe once or maybe in batches every single time you want to get new emails into your compliance system. So what you would do is you would give it source host information, where is this file coming from, and give it a source directory on the AFS, and we would use FTP to get this file over there. And I'm not going to demo it right now. It takes a while to move files across the network. So, jumping over to the next app, our email and attachments parser, and this is a big differentiator for us. Basically, we've developed a parser that is very good with parsing from the AFS and can parse attachments as well as email and retrieve all the relevant metadata in an email from importance, BCC, CC, to what category this email was, how you flagged it, and so on. So what you would do is just then give this app a certain file or directory within the AFS, find it in the AFS, and then run this and then set this app to run. And what the app will do is then land this in a table of your choice, all of the email metadata, email text itself, and documents parsed. Those documents would have to be Word, any docs, any text files, also CSVs, as well as Excel files. We could parse all of those attachments, and we're working on parsing more as we see relevant. Okay, so moving on. And next we have our email cleaning app, and this is easily the most important part of the whole process, and where I think most of the analytic logic is spent. It's very important to clean email, and we all know the email is very messy. There's a lot of junk in there, a lot of stuff that you probably don't read on a daily basis or would want to read. So let's jump into the app. And what this app does is it goes through paragraph by paragraph using our machine learning operators, SVM and naive Bayes, to classify this email as the body of the email or something else. And that something else may be echoes. It could be just spam. This email is spam in general. Or it could be a signature or a disclaimer. And it's important to note that these signatures and disclaimers are common to fraudulent emails and they're common to regular emails. It's simply noise within the signal. So we're going to try to separate the signal from noise in this process and take only the body of the email. So let's dive in and see how it works. All right, scroll over to the right here and look at the first one. Thanks for your email. Since I talked to Jim, I've been sucked into the California energy crisis and I'm not concentrating on the workouts just yet. Hopefully we can cut this email right here. And as this is an echo, and you probably don't want it. So let's see how we did. And here we go. We cleaned the email very nicely. Cut out all the echo, cut out all the junk, all the disclaimers and signatures. And we'll move on to the next email. Here are the most recent demos. A second email will provide another memo, and you'll see a big signature here with lots of information that we really don't need, and as well as an echo behind that. And if we click on the email, once again, we've cleaned it very nicely. And maybe just one more for good measure. Teresa, I have not spoken to CIG directly. And then we're going to end off. Robert is part of a very short signature, so hopefully we can cut that out. And once again, we clean the email. Okay, moving on to the next app. That would be our email compliance rules simulation. And this app is your production environment right now. This is the solution that will get the feds off your back. Basically, we're running a large series of rules against the email data set, and we're flagging certain emails that correspond to these rules. And I'll just dive into the app to talk more about it. We have certain rule categories, and we can choose all. These are just some of the categories that of rules that you can choose from. Many times, customer complaints are typically easy to find. Also, legal issues, anything confidential. If you send over any social security numbers, that will most definitely be flagged in this app. And then we allow you to choose a certain rule set. This rule set could be very modular. It could be very heavy towards a certain kind of rule. It could be, very heavy towards admin or very heavy towards insider trading. Who knows? So we'll go down to the output we have for you today. And here is the raw output from our text tagging function. We have a function in the database called text tagger, and that will perform the rules-based analysis that many other rules-based point solutions out there that functionality. So here we see the tag, that's the rule that gets fired, their sender and their recipients, and also the contents and the keywords. And here is where the rule is made up from. So if they contain these two words, share and don't, for this email, if those words are contained in the email and they are within 6 words of each other, we're going to fire this. We're going to fire a rule on this email, and we can take a look at it and see where we highlight the words that fired this rule. It might save an analyst a lot of time and a lot of time spent at the eye doctor to pick these words out, highlight them, and also enlarge them so they can see very quickly what fired this rule. Okay. Now we'll jump over to a more global view. You might not want to look through all of your emails individually, so we have a Tableau server dashboard that we link to Aster, or link to App Center, I should say. And here we have your rule simulation over time, a series of months that are broken out, and many by rule category for each of these visuals. We also have our top rule breakers and our overall rule composition. So several ways to look at these emails. And it's very interesting over here. We hover over this and see that October 2001 was the month that the most rules were fired. And if you remember the Enron email crisis, this is when all this information is made public. They were long suspected of fraudulent activity, but this is when it was finally proven and brought to light. Therefore, people were scrambling to hide things, and it fired a lot of rules. And maybe we'll just take a look at the customer complaints that happened in this time period. And we can click on this and then drill down into the individual emails themselves. By sender, we can hover over this and see the email. All right, moving on to the next app. We have our text tagging app, which is basically kind of a playground for creating new rules and trying them out. What we allow you to do is to select up to 5 rules, to create and select up to 5 rules in this app. Rule 1, basically we have, just like I explained before, we have a phrase 1 or phrase 2. It can be only one phrase, the inclusion of one word, or it can be 2. And what we're looking for is a minimum words between and a maximum words between if these words are included in an email. And that will tag this email. That will cause a rule to fire in production terms. So we have a run for you already. I'll just click on this and close the output for now. But what you'll see are all the rules are populated. So first we have foreign investor, client irate, will not tell, cover losses, and wire transfer. And let's take a look at that example and see if we can find anything. So if we scroll down here, we see lots of rules are firing on several emails over here, and it's a conversation between Bill King and Greg Bates. So we'll start with the first email. A very important client and partner of ours is irate about losing capital investment. Then Greg Bates says, we can't afford to lose this client. Let's contact a foreign investor and don't tell anyone. And then finally, my foreign investors, and please make a wire transfer, signaling the fraud in the action that's actually happening here. So this is just a simple example to show you how we could find fraud using rules in the email database. All right. So moving on to the next step, and that would be our email graph analysis. And we like to think of this as a graph problem. Basically, your nodes, in this case, are people. and your edges are the emails that they send back and forth to each other. And there's a lot of algorithms that we have native to our database that can produce a lot of good metrics that go along with this. So what we have for parameters are a spam threshold. I feel like this is the best part to really explain how we're filtering out spam. So in this case, 20. If you send 20 emails to more than 20 emails to someone, and they don't respond back to a single one, we consider that conversation to be spam. And then we choose if we want a directed or undirected graph calculation, and then a number of nodes to visualize. There's only so many nodes in your email database that can fit in an HTML window, and we'll look at the top 1,000 in this case. Let's click on our output, and let's check out our graph. And I think what you would notice is a few of these executives and their direct reports directly surrounding them, very much only talking to their manager in this case. And we see the modularity algorithm, what colors these nodes, that's the modularity algorithm. And it gets it pretty much right. It kind of divides these communities from executives and their direct reports. And then we might search for betweenness. We can filter down on betweenness and see that these people are the ones that connect distinct communities more often. And just my hypothesis that might be an indicator for fraud. Okay, so let's tap out of this and see let's see what spam might do to our email graph. And overwhelmingly, you see this big cluster down here full of people getting emailed. And that's very suspicious. And you would think, if you were calculating graph analytics, these might really pop out, but it really shouldn't, is the point. Because we look down here and see that schedule crawler is just pinging each of these people. That makes up most of the email in this graph, and that's just junk. So that's how we filter that out. Okay, and the last app we have for you today is the Solr Query app. What we've done is we've integrated very tightly with Solr, and Solr is a production environment for Lucene. Very much like Aster is an MPP environment for database analytics. So what we do in this app is we rapidly pass the text data from Aster into Solr, and we index that. And once it's indexed in Solr, it's available to be searched upon very, very quickly. So ad hoc search over 1 million to billions of emails is very possible within just a few seconds. So you can iterate quickly and dig down to something you really want to find. Okay, so let's take a look at this Solr viz. I'll go ahead and enable scripts here. All right, and we're going to look at the Enron collection. We also have a Wikipedia collection in here too. So what we do is we then have search parameters, also other options if you want to specify dates, if you want to add certain fields, and if you want to look at certain number of results per page. And then we have the ability to sort. So what I'll do is just a search that I've kind of found that gives pretty interesting results is a proximity search. So we'll search type proximity. And the first word will be bad, and the second word will be investment. We know Enron made a lot of bad investments in this time. And we'll set a distance of 3 between those words. And let's go ahead and search. You'll see almost instantaneously we've brought back some results. And these results point out some of the bad investments that Enron made. And then, if we want to dig down deeper into this email, we can see more and read the whole email. And then we can retract that as well. And then continue to go down this list and find where bad investments were added to an email. And I think that's the end of my part, and I'll hand it back to Dave at this point.
Thanks, Matt. That was great. Always like to see those apps in action. I'm going to put up a slide now that is really around Q&A, so please continue to type your questions in. While the demo was going on, I did get to look at a couple of questions. And one that is really this came in at the beginning of the talk. And it's this. Does the solution only work on email files, or can it be used against other types of messages? I will go back to a slide right here and give you, sort of the input on the sources on the left. I mean, there are multiple types of sources that this analytic process will work against. Basically, any digital file that exists and is logging messaging could be, subjected to this. So yes, this does work on, text messages, tweets, blog posts, web comments, anything like that. And again, the process here, the analytic process, is fairly generic and will serve whatever purpose it is, whether it's to do some compliance detection or to do some sentiment analysis. It all is very generic. Let me go back now to this slide and look at a couple other questions that are coming in. Someone's asked. Go ahead.
Go ahead, I see one. Someone said this is a great analysis done on emails. Can you talk more about the detection of email signatures and disclaimers? I don't think I elaborated as to the actual statistical methods that were used here. We used our naive Bayes text operator as well as our SVM, support vector machine operator, to detect these signatures and disclaimers when they come through. And we set a certain threshold in the mix there, working with our clients to find that this threshold really gave us the most just the most desirable threshold for defining a signature or disclaimer. And we had to do some manual screening for that, with many people in the organization to get this right. It was very important to our client to set that threshold correctly. So to close, naive Bayes text and SVM, which are both operators inside the Astra database.
Great. Thanks, Matt. I'm going to pitch this one over to you as well, Matt. I think you probably have the answer to this. Is the ETL process fully automated, or does it require specific code building?
The ETL process, that's the process from actual email, from files, actual PST files to the clean email. Is this process fully automated? For demo purposes, I kind of go through it in a very distinct way, and I take you through the steps. It could very well be fully automated. I could actually go back to App Center and show you how you could schedule these runs. So that's how you would automate something like this.
Great. And then another one, this is, again, I know you've answered this before, the size limitations on the email logs that come in.
There weren't any size limitations that we detected on many of our projects.
Great. So there are ways to reach out to us post this webinar. You can always reach out to your account executive to find out more about this email compliance solution that we presented today. And you can always email me, and I will put you in touch with whoever that is if you don't know who to contact. The IDC white paper, which talks about the value of consistent reusable analytics for big data, which is really embodied in what Matt just ran through was in a web browser. Is a web application that really enables all users in the organization to access and tap into the power of the big data analytics that are underlying them. So, that was the focus of that paper. And then we have a website as well that you can learn about all of our other big data apps. And if you hold on one second, I'm going to forward to another slide. This is a listing of the apps that we have actually done webinars for. So we did on-site search a couple months ago, and that recording is available. The customer satisfaction index was done as well. Also, recording is available. And today, you've just finished the email compliance one. I'll put a plug in for 2 more coming up in the following month. We have cybersecurity and log analysis coming up on October 8th. And then on October 29th, we have our product recommendation apps. And then the date for the last one is not yet determined, but it'll be announced, and you'll see that. So if you prefer, this webinar format for learning about it, please feel free to, attend these webinars and the previous recordings, or if you want to go to our websites, just, note this that they're available. All right. I'm going to take one more look at the question inbox. Looks like
I've been looking at them too, so I think I can go ahead and answer if you would like to.
Please go ahead.
We have a question around the method of rule sets when typical words aren't used and the conversation improvises in due course and basically doesn't use any typical words that our rules might catch. How would our system catch? And that's a very hard thing to get around. Definitely a big challenge. But we have text analytic functions that we are going to apply to the future on the actual compliance issue itself. We need to get more ground truth in developing that solution and developing that model. We know many organizations aren't too keen on actually giving us what happened as fraud. And we couldn't get that from a lot of our clients. But in the future, when we get some ground truth, we can apply more statistical learning methods on top of these emails to catch that conversation that isn't caught by our rules. And then we have what stack is needed to implement this, and this is fully Aster. Aster, and then if you want the Solr piece, you would need a Solr cluster as well. And then let's see.
I see one other one that was probably relevant to the general audience. Does this ship with primers? Standard set of rules. Is there a sharing community for these?
No. These rules
are all
just made up on the. These rules were made up on the fly for demo purposes.
Right, and so basically the business logic behind the rules would be based on the implementation that was being done. So if you were like an HR department, obviously those rules that you enforce for your particular company / geography would be, embedded in your business rules that would be implemented. And then some of the obvious ones for bigger national, SEC laws, obviously those are well codified and would be easy to implement. Okay, well, I think that's about it. If there's no more questions, and if we didn't get to yours, I will we'll respond to them in email. I will thank you for attending and return you with 15 more minutes of your day. All right, thanks everyone.